triangle. We're going to go back to my lovely little rectangle and parallelogram. Except I'm going to cut it out this time. What was the area of this?
6. Oh, then that's 23.
What's the area of that again? What's the area of that again?
6.
What's the area?
3.
How do you know? Yes.
It's a triangle, so you do the base times height times by space times height divided by 3.
Why?
Because it's half of this. It's half of the parallelogram. It's always half.
If you square a rectangle, or turn a rectangle into square a triangle, or turn a triangle into a rectangle, you get 2 equal parts, right?
Yeah.
How do you figure out the area of a rectangle?
You make the parallelogram out of the triangle, and then you can figure out the area of the parallelogram really easy. You could imagine like a second triangle, so it's like a rectangle, and then get the area of that divided by 2.
Yeah. These 2 triangles are identical, right? If I take this triangle and I place it over top of this triangle, I wish they were a little bigger, but look, magic. It's 1 triangle. Ooh, okay. It's almost 1 triangle. Ooh, ah. But magically, it's actually 2.
Whoa! You should be a magician.
I know. The point being that to figure out the area of a triangle, I want to figure out the area of that triangle. What I can do is pretend that it's a rectangle, like that. Not quite, actually. It won't end up being a perfect reflection, at least not this one. What is the area of my new figure? What's my base?
4.
What's my height?
4.
Okay. What is the area of all of this?
16 units. 16 centimeters. 16 centimeters squared.
Okay. So the area of the rectangle is 16 centimeters squared. But I don't have a rectangle. What do I have?
Half of that.
Half of a rectangle. So the area of the triangle is 8 what?
Centimeters squared.
8 centimeters squared. Area of a triangle, base times height divided by 2. Now, this made a rectangle. Well, actually, it made a square, but anyway, what happens if my triangle is not a right triangle, but instead a triangle that looks something like this? How am I going to figure out the area for this triangle? Yes?
The same thing that we did for the other
So I turn it into a parallelogram. And then I measure what? Okay, the height, which is 2 centimeters, and which is, which apparently is a number that I'm fond of. Then what do I do?
Times those together and you get the parallelogram.
Okay, so the area of my parallelogram is
8 centimeters squared.
8 centimeters squared. What's the area of my triangle? I don't want the parallelogram.
4 centimeters squared.
Why, thank you for putting your hand up. Yes.
4 centimeters squared.
We divide it by 2. The area of the triangle equals 4 centimeters squared. Did you get that?
Yes.
Does it make sense?
Yeah.
Does it make sense? So. Okay, the area of a triangle is 7 centimeters squared. What's a triangle look like? Mm-hmm.
2 centimeters is the base.
Okay.
And 5 centimeters. 6 centimeters is the 10 centimeters is the height.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the area?
20 centimeters.
What's the area of that?
20 centimeters.
Okay, and if I now divide it in half, and we'll pretend that my line was straight, what's the area of the triangle?
10 centimeters squared.
But I need 7 centimeters squared. Yes.
You could do a base of 1 centimeter and a height of 7 centimeters.
What's the area of that rectangle?
Okay, I see.
7 centimeters squared.
I mixed that up.
So the triangle is
We need 4.
Oh, I get it.
3.5 centimeters squared. Okay? I'm running out of space there. Next, yes.
So we'd have to do 5 centimeters height and 2 centimeters. No, 4, 5. Because we're doing. Oh, I got it.
Yeah.
You have to do a height of 7,
Okay.
and you could do a base of 2,
Okay.
and then that's your rectangle.
Okay. What's the area of that?
14.
14 centimeters squared. You got to remember that, you guys. So now, what's the area of the triangle? 7
Centimeters squared.
Good. So when you're looking at the area of a triangle, you have base times height divided by 2. Still measured in units squared. But if you're given the area of a parallelogram, you need to find factors of that number, right? So if you're given, for example, 40 centimeters squared, you can do 8 centimeters times 5 centimeters. You can do 2 centimeters times 20 centimeters. You can do 1 centimeter times 40 centimeters, and so on and so forth. Yeah? Do you guys follow?
Yes, we do.
Pay attention, please. If it is the area of a triangle, what do you have to do first? Before you can look for the factors. Yes.
Gotta turn it into a parallelogram.
Yeah. You need to multiply it by 2, then look for your factors. So if your area of the triangle is 10 centimeters squared, then the area of the parallelogram is 10 centimeters squared times 2, which is 20 centimeters squared. And then you can find your base and your height. Do you understand why? So on and so forth. Why is that?
Because it's half of the rectangle.
Yeah. When we're looking at the factors, when we're looking at base times height, that's what we're talking about when we're looking at factors, right? In our rectangle or in our parallelogram, it is base times height, or base times height. In our triangle, we're taking that and dividing it by 2. Because we've got 2 halves to the triangle. Base times height divided by 2. Base times height divided by 2. So to find the base and the height, which are basically our factors, in a triangle you have to get back to the parallelogram or the rectangle before you can actually find the factors. And we saw that when we were doing this. 1 times 7, 1 centimeter times 7 centimeters equals 7 centimeters squared. But that is the area of the rectangle that this triangle is based on. In order to make it work, we had to double our area to 14 centimeters squared in order to be able to divide it, to find the base and the height that would allow us to divide it and get a centimeter that had 7 centimeters squared. Thumbs. Got it? So, not at all.
That's kind of like
All right.